You have no ads, so that's good.
Okay, so now we're going to work this problem. We need to find the maximum shear at C. I've got three set of moving loads. So the first thing we need to do is find the influence line for shear at C. So I'm going to use the Mueller-Breslau technique we talked about previously. So I'm going to come to C, and I'm going to imagine this shearless connector. I've still got my roller at B and a pin at A. And I'm going to put a positive shear on the left side and positive shear on the right side. So let's see how this structure is going to move. So the left side edge, right there at the connector, is it going to go up or down? Down. And this right edge, is it going to go up or down? Up. We've already talked about these slopes are the same. So you can see the height here would be a lot larger than the height there. And we can find that in just a second. So let me redraw it now. Hopefully a little better to scale. So again, this is going to be the shear at C. And let's see, that's 2. That's right about there to there. So I'm going to have this, something like that. My dimensions are 2 meters for the left side and 6 meters for the right. Remember, we know that this change in shear is 1. So let's see, 2 to 3. So this side, the base of the triangle is 3 times as big as the left side, right? So that means the height is going to be 3 times as big as the left side. You see that? So if I just called this H, this would have to be 3H. See that? And then I know that 3H plus H has to be equal to 1. So solve for H and you get a quarter. So that means this is a quarter and this is, or negative a quarter, and this is positive 3/4. You guys see that? So this is going to be 1/4 and this is going to be 3/4. So I drew my influence line. So now let's solve the problem with this set of moving loads from right to left with this influence line. How many cases do we have? 3. We have 3 loads, we have 3 cases. So let's start with case 1. Just give me a second to redraw the influence line. There's the rough shape. We've already found that this is negative 1/4 and this is 3/4. So I'm now going to let my first load come up here. So there's my 1 kilonewton. And then 1 meter back is 4 kilonewtons. And then 3 meters back is 6 kilonewtons. So I'm now going to need 3 values off this graph. The first one I already have, it's 3/4, right? So I need to find the value here and here. What's the slope of my line? Well, the rise is 3/4 and the run is 6. So that's 3/24, which is 1/8. You guys see that? So if I move 1 meter back, I drop 1/8. So if I start off at 6/8 and I drop at 8, I should be at 5/8. If I move 3 more meters, I should drop 3 more 8s. That should drop me back to 2/8. Everybody see that? Just interpreting values off the line at these fixed distances. So therefore, my shear at C for case 1 will be the front load, 1 kilonewton times 3/4 plus 4 kilonewtons times 5/8 plus 6 kilonewtons times 2/8. What's all that? That's 3/4. That's 2.5. That's 1.5. That's 4.75 kilonewtons. Okay. Now what do we do? Oh, and also I should say the logic here probably is, since the positive side is way bigger than the negative side, I'm not even going to look for negative contributions. I'm going to always, as I move my values over here, I'm always going to use the positive side. So what happens in case 2? So, just have to be patient while I redraw this. So now I'm going to let the second load come to the top, maximum value. So that's my 4 kilonewtons. Of course, 1 meter in front. Oh, I didn't give myself much room to write in there. Sorry about that. 1 kilonewton. And then 3 meters back is the 6 kilonewton force. And again, I need values there, there, and there. Now this one I already have. That's the 3/4 value. The slope of this line is still 1/8. So if I move 3 back, I'm going to drop 3/8. And if I start at 6/8 minus 3/8, I get 3/8, right? 6 minus 3. The slope over here is the same, but remember down here at the bottom, this is negative 1/4 or 2/8. And if I move 1 meter forward, I'm going to change by 1/8, so this becomes negative 1/8. So all I have to do now is add that up. So my shear at C for case 2 would be my 1 kilonewton now is multiplied by negative 1/8 plus 4 kilonewtons, that's the second load, that's going to be multiplied by 3/4 plus 6 kilonewtons, that's multiplied by 3/8. I don't know what that is. 5.13. 5.13?
Yeah.
0.13?
Yeah,
0.125. That's close enough. 5.13. And that'll be kilonewtons. So that's bigger. We have one more case to do, and that would be where, what would happen? Now the 6 would go to the top. The 4 would do what? It'd be 3 meters to the left, which is off the structure. Right? And then the 1 kilonewton is 1 meter in front of that. That's off the structure. So case 3 would just be the 6 kilonewton sitting right there at the top.
You just don't account for those first two?
Well, they're off the structure. Right? You can imagine a situation where a vehicle is driving across and all but the last load, and remember, it's pretty short. It's only 2 meters. It's a pretty short little structure. Right? So if the last load is sitting here at C, the front two are off, so they won't count. So I'll try to squeeze it in here for you. Case 3. So again, the influence line hasn't changed. And all we have in this case is the final 6 kilonewton force. And we know that value. That's 3/4. So the shear at C for case 3 is just going to be 6 kilonewtons times 3/4, which is 4.5. So this becomes the max value. So the shear at C max would be 5.13 kilonewtons. Now let's go back and talk for a minute about live load and dead load, uniform live load and uniform dead load. Now if I put a dead load on this structure, would the result be a positive or a negative value? Well, there's more positive area than negative area, so you get a positive value. So it would increase all these by that positive amount. Now what about the live load? Where should I put it to create the maximum positive effect? Yeah, I should start it at C and let it go all the way to B. That would just correspond to the positive portion of the curve. Now if I did want to do negative, what would happen? Well, I'd only get a little bitty negative, relatively smaller negative contribution. The dead load is still all positive. I can't control that. So they would probably cancel out and make it positive. So it'd be difficult to generate a negative, much of a negative shear for this particular problem. And that's with the truck moving from right to left. We turned it around and went from left to right. All that would turn around. I get a big negative value. Okay? All right. That wasn't so bad. That was only about